Alright, so I want to talk to you about section 8.2, which goes into length, area, and volume in the metric system. So just to remind you, here's our basic scale. We have three main units of measure that we're going to study. That's the gram for how much something weighs, its weight or its mass, and meter is how long a meter stick is, about 39 inches, is our base unit, and liter, like a liter of pop. We know I think we all know that liter of pop now, what that looks like. So we've got to, at least in our mind, what those three units look like. Gram is real tiny, though. It weighs almost undetectable. If you had that in your hand, I don't know that you'd feel it. When you have 1,000 grams, that's a kilogram, and that you can feel. It's about 2.5 pounds. So it's still not super heavy, even at a kilogram. But those are our basic units. Then we put prefixes in front of these to change the decimal move. Everything in the metric system is a base 10 philosophy or units there, so it's easier for us to convert because we're just moving our decimal point left and right because of the base 10, like our numbers. So it's much easier than our old English system where we have measures all over the place, like 12 inches is a foot, and then it's 3 feet is a yard, and we have so many yards is a mile, and it's something different in each unit, so we can't just move our decimal points. So it kind of makes us appreciate at least this is easier to convert. All right, so when we put the prefixes in front of it, if we're moving up the scale, we'll move our decimal point to the left. If we're moving down our scale, we'll move our decimal point to the right. Okay, so basically, whenever we would move linear units, and then I'm going to talk about the square units in this section, but just to remind you, if you are going 3 centimeters, and you want to know how many millimeters is that, these are considered linear units. They're to the first power, so it's just one directional. So a centimeter would be here on the scale. A millimeter is 1 down, so 1 move down would move the decimal 1 right. Down is right. The decimal point is understood at the end if you don't see it, so 1 place over makes that a 30. It moves the decimal point over 1 place, but you couldn't quite squeeze in there. So that's linear units, but what we're going to see when we go on in this section is square units and cube units. So let me tell you why there would be square units. Square units come from the area idea. For example, if you measured out 1 centimeter horizontally, 1 centimeter vertically, made a square out of that, the area in that's the area, is a centimeter times a centimeter, which we multiply length times width to find area inside of a rectangle. So length times width, 1 times 1 is still 1, and then centimeter times centimeter is square centimeters. So the area inside of that is considered the 1 square centimeter. Another example, if we had 2 centimeters, we would multiply length times width, and that would be 4 square centimeters. So that's the area inside of this. Another way to think of it is like this board. If I was talking about the whole area that I see on the board, I would say the length of the board times the width of the board, and then the area inside of that. If I were painting it, I would want to know how many square meters, square yards, if I was doing the old customary units, but you'd measure your length times the width to find out how much space is on a two dimensions. So that's what square units looks like. Another one that comes up in the book is what a hectare is. A hectare is a hectometer times a hectometer. We know a hectometer is 100 meters, if you can kind of visualize what a meter stick is, and then 100 of those back to back. So a hectometer times a hectometer is called a hectare. It's a hectometer squared, 1 hectometer squared. But that's what they measure, what we would normally measure acres in the metric system, is in how many hectares is that. So just that could come up in your reading as well. All right, so if we're converting like 3.2 square meters, and we want to convert that to square centimeters, we need to remember there's a 10 difference by 10 vertically, and then a difference of 10 horizontally. So we've got 2 dimensions going now, so it's 2 decimal point moves for every move on the scale, and that's again because it's a 10 by 10 or 100 whenever you take the length and the width, the 2 directional, 10 difference in the length and 10 difference in the width for each time you move in units. So 10 by 10 is going to be 100. It's going to be a difference of 100 every time you move on the scale. 100 means 2 zeros, so you're moving 2 decimal places. So whenever you're going square units and you're using our scaling, you're going to move by 2 decimal points each time. So whenever we do 3.2 square meters, we're saying meter, we're going to centimeter. That's 2 moves, but it's 4 decimal points. You double the amount of decimal points. Down is right, so 1, 2, 3, 4. 1, 2, 3, 4, okay. Making sure. So 32,000. A lot, right? Let's do that again. Let's say we're going 5.3 square centimeters. We're going up to a decameter, a square decameter. So from centa right here, we're going up to deca. That's 1, 2, 3 up. Up moves the decimal to the left, or if you're doing your scale horizontally, you'll have a left move. So either way you think about it. But we're definitely moving our decimal point left when we go to these larger units. From a small unit up to a larger scaled unit, we have to move our decimal to the left. So centimeter, 1, 2, 3 to deca, 3 places, but it's 2 moves for every place. So 3 times 2 is 6. Again, it's 2 moves, 2 moves, 2 moves for each time I move on the scale for a total of 6. So going to the left, 1, 2, 3, 4, 5, 6. Fill in a bunch of those zeros there, and it's 1, 2, 3, 4, 5 zeros. 5, 3 would be the conversion. All right, so now let's go up to volume, the other thing you'll see in this section. So volume is 3-dimensional. We've got length, width, and height. And I'm not great at drawing those little boxes, but you know how to draw a box, maybe connect. If you can kind of see that as being 3-dimensional like a box, if I had a centimeter wide, a centimeter tall, and then a centimeter here, and I think I said long, but your 3 dimensions, length, width, and height involved. A centimeter, had that square on that. 1 centimeter, 1 centimeter, 1 centimeter for the 3 dimensions. When I multiply that together, that's a cubic centimeter. Centimeter times centimeter times centimeter is centimeter to the 3rd. We call that a cubic centimeter. So how much liquid I can fit in that, or how much I can put inside that, the volume of that is a cubic centimeter. 1 cubic centimeter. So now when we use our conversion scale, a centimeter, if I were converting it, say, a decimeter to 1 unit different, there's a 10 difference between every part on the scale. So there's a 10 by 10 by 10. There's 10, 10, 10, or 1,000 when you multiply length times width times height. Each dimension has a difference of 10 on the scale. So we're actually going to move our decimal point 3 places when we do cubic units, when we're converting between cubic units. All right, so let's say we have 3.2 cubic millimeters. Millimeter, 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 3-dimensional. So there's a difference of 10 for all 3 dimensions. So I'm going to convert that to just one place, this first one, to cubic centimeters. So 1 move is 3 decimal points. And again, if I'm going up, I move my decimal to the left. So decimal point, 1, 2, 3, 0.0032 is the conversion. So again, if I'm doing cubic, it's 3 decimal places for every move on this scale. Okay, let's do 5 cubic decimeters, and let's convert that down to cubic millimeters. So deca to milla is 1, 2 moves, but I'm going to move it 3 decimals for every move, so 3, 6, or 2 moves times 3 places makes 6. So the decimal point is understood here. I went down 2 places, but I'm multiplying it by 3 makes it 6 total places. 1, 2, 3, 4, 5, 6. So I've got to fill in actually 6 zeros there. So a whole big bunch, 5 million cubic millimeters. All right, so that's how we use our conversion. Let's do one more time. Let's go 0.02 cubic hectometers. And let's move that to, up to, or down to, let's do centimeters. I want to try to show you a lot of moves, how that you multiply it. Hecto to centa, that's a long move. That's 1, 2, 3, 4. 4 places, 4 moves, times 3 for each move makes 12 total decimal places. So, and I went down. Down means right, so I'm going to go 12. Maybe I should have rethought that. 1, 2, and then 10 more places. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then fill in with zeros. The 0 in front is non-essential, so you've got a 2 and 10 zeros. Okay. So that's how we do conversions if they're both cubic. All right, now last thing in this section is one more conversion table to this. Is on page 447, if you're following along, is some conversions, some things to be aware of. Now, if you ever use a medicine, child's medicine dipper to administer medicine, then you might know that a cubic centimeter is commonly referred to as a cc, cubic centimeter. So a cc, 1 cubic centimeter, is exactly the same thing as an ml, a milliliter. It holds a milliliter of liquid. So that's if you're administering Tylenol and the little, I'm trying to think of a better word for that, but anyway, that you pour into the child for maybe they need 5 mLs or 5 cc's of Tylenol. So these are the same measure. You'll see on the display that it'll say a cc and an ml. They're exactly the same. So that's a truth. If you did a cubic centimeter, if you drew out that little box I had earlier, a centimeter, 3-dimensional centimeter, what you could pour in that is a milliliter of liquid. Okay, the next measure is a cubic decimeter holds a liter of water. So if you drew out a decimeter, which is, I don't know, maybe about like that, a decimeter 3-dimensionally, and then went deep that far in. Again, I didn't draw that very well, but and then poured in the liquid into that. A decimeter cubed holds a liter of liquid. And then lastly, the last main one that we'll use is a cubic meter, is a kiloliter of water or liquid. Cubic meter, so that's going to be about, that far, about 39 inches, long, tall, and wide. And you poured water into that, that's what a kiloliter of water would look like. If you can kind of picture that, and then in your homework it will ask you, what do you think is a reasonable measure? So you can kind of have in your mind what that looks like. That will help you with that. Okay, let's do one example I see in your book with a swimming pool. This is example 7 on page 448. And it says you've got a swimming pool that's 18 meters long, 9 meters wide, and 3 meters deep. Find the volume of the pool in cubic meters, and then change that to kiloliters. All right, so if you can kind of visualize, and they have a nice little picture here in the book, but visualize that's a swimming pool. It's 18 meters long, 9 meters wide, and then it's 3 meters tall of water. So the volume, the formula we'd need for this is volume is length times width times height. Like we were doing earlier, just the 3 dimensions multiplied together gives you how much fits in that for volume wise. So multiplying that together, you can check that out. It is 486. And then meter times meter times meter. Notice they all need to be in the same units for this to work, is cubic meters. And then the question said, how many kiloliters is that? Well, from what we just had earlier, a cubic meter is a kiloliter. They are the same measure, so we could also say that is equivalent to 486 kiloliters. So just be aware of that little conversion. Now, if it would have said change it to, on the scale, we could have changed it to centimeters, decimeters, cube, or something like that, and we have a more complex conversion. But just to move it to kiloliters, it was exactly the same measure.